Hey guys, this is a video to help you out if you are struggling with calculating force. Just as a quick review, this worksheet we worked on in class today on January the 10th. My 6th period class missed this, so I'm posting it mostly for them. But just as a quick review, when we're calculating weight, that is a force. So force is a push or a pull, and think about it like if you're standing on a scale and the scale is measuring your weight. It's measuring your weight because gravity is pulling your mass downwards and it is pressing you into the scale, and that compresses the springs inside of it and causes the dial to record your weight. So in the blanks here, weight is a measurement of gravity. Acting upon the mass of an object. And anytime you're calculating weight or force of something falling, you're going to use the gravitational constant because that's how quickly something is moving towards the ground. And the gravitational constant for Earth is 9.8 meters per second squared. Any kind of force is going to be measured in newtons. And since weight is a force, just like an applied force, we're going to use newtons to measure that. Now, one thing to make note of is that a newton is equal to a kilogram multiplied by a meter per second squared. And you can convert that back and forth to use to cancel units when you're solving for mass or acceleration. And I'll show you an example of that a little bit later. So if we have one object that has more mass than another, the object with more mass is going to weigh more because there's more mass for gravity to pull against. Think about it like if you're sitting on the couch and you have a small dog and a large dog. Which one would you rather have sit on you? Probably the small dog because he weighs less because he has less mass. Also, gravity is also going to affect things differently based on proximity. So as you move farther away from a large object like, say, the Earth, its gravity affects you less and less. So an astronaut that's going to the moon, we talked about how mass does not change with regards to location because mass is simply the amount of matter in an object. So mass is going to remain the same. While weight does change. Now, as he gets farther and farther away from Earth, he's leaving Earth's gravitational field, and gravity has less of an effect on him. So the acceleration of gravity is going to decrease pretty rapidly as you exit the atmosphere. While he's in space, he's going to be weightless because there's not any gravity affecting him. And then after he gets to the moon's gravity, that's where he's in proximity to, so the moon's gravity takes over. And the moon's got much lower gravity than Earth, so he's going to weigh less either way. Now, I've told you that the formula for force is mass times acceleration. And if this were a regular math problem, and say it was like 2 is equal to x times 3, or 3x, and I asked you to solve for x, you would be able to do that because you would just divide both sides by 3. So in this case, if this was x and I wanted you to solve for mass, you would simply divide both sides by the acceleration. So it's possible to rearrange this formula in order to solve for mass or acceleration if that's what you know you're solving for, rather than just plugging everything into this formula and working backwards from it. The triangle here is called the formula triangle, and I like to show this to students because it's just a good visual memory thing for people to help remember formulas. Anytime you have two things that are multiplied, they're going to go in the bottom of the triangle, mass times acceleration, and then the other variable that you're solving for goes up at the top. There's your force. So you're going to cover up the thing that you're solving for. In this case, I'm solving for force, so my formula is mass times acceleration because they're next to each other. If I want to solve for acceleration, here I'm left with force over mass, and there's a dividing line between them, so you're going to take force and divide it by mass. Okay, you can do the same thing with acceleration. Oh, I did that wrong. So mass actually should be acceleration, sorry. Acceleration is force divided by mass. All right. Now, problem number 2 is just simply an introduction to procedures. Like, how do I go about solving this problem? And what I have learned over the years is go ahead and make note of things in word problems that are significant. So right here, this question, what is the force? That's significant because it's asking you to solve for force. So then I also see 1 kilogram. That's a significant thing. And that's really all I see at the moment. So let's read the rest of the question. What is the force on a 1 kilogram ball that is falling freely due to the pull of gravity? All right, well, pull of gravity is also significant. Anytime you're calculating the force of something falling or the weight of something, unless told otherwise, assume that those objects are on Earth, and you're going to use the the acceleration 9.8 meters per second squared, because that's the Earth's gravitational constant. So the next thing I like to tell students to do is these variables in the formula, go ahead and list them out underneath your problem, and then fill in what you know. So at this point, we know that we're being asked to solve for force. And I can come up here and tell you that the formula for force is mass times acceleration. Mass times acceleration. So I'm going to write in mass times acceleration as my force. Okay, reading on, 1 kilogram. Well, kilogram is a unit of measurement for mass. So I'm going to write 1 kilogram right here. And then acceleration due to the pull of gravity. Well, pull of gravity is 9.8 meters per second squared. All right, so now I have everything I need to solve for this formula. I'm going to come over here, and my next step is going to be to rewrite my formula. Force equals mass times acceleration. And it's really important that you get into the habit now of writing those formulas and include your units when you plug numbers in, and make sure that your unit is on your ending. Because as these problems get more complex as you go into higher grade levels, they're not going to be one-step equations. They're going to be 2 and 3 and 4-step problems. And if you don't have your correct units on there, you're going to get confused, or you're going to end up like NASA with a $1 billion telescope that doesn't work because somebody measured in metric and then somebody built the thing in standard. So I'm going to plug my numbers in. Mass is 1 kilogram. And acceleration is 9.8 meters per second squared. And when I do that math, 1 times 9.8 is 9.8. 9.8. That is not a correct answer because I don't currently have any units on it. If this were 1x times 9.8y in your math class and you wrote 9.8 and left it at that, you'd get the answer wrong. And you would know that because you left off the variables. Units are just like a variable. So you've got to put in that kilogram times meters per second squared. And then remember up here at the top, I told you 1 kilogram times a meter per second squared is the same thing as 1 newton. So what you have here is 9.8 newtons, and that is your correct answer. Okay. Now I said I would show you how to do one of the others, mass and acceleration, and how to cancel units. So I'm going to do the same procedure for this one. I'm going to underline the things that are significant. What is the mass? I'm solving for mass. So if I come up here, my formula for mass is force divided by acceleration. And then I'm going to continue reading. This is a person who weighs 500 newtons. Weight is a force. So 500 newtons is my force. And this is a person. People exist on Earth. I'm going to use 9.8 meters per second squared. All right. Coming over here, my next step is to rewrite my formula. Mass is equal to force over acceleration. And I'm going to plug my numbers in for my variables. So 500 newtons. But I am going to, instead of writing newtons, I'm going to write this long form, kilograms times meters per second squared. Because when I divide this by 9.8 meters per second squared, do you see how I've got this and this? Anytime you divide something by itself, you get 1. And so that basically means that this meter per second cancels this meter per second, and all I'm left with unit-wise is kilograms. So if I continue to simplify my problem, 500 divided by 9.8, I think I don't have my calculator with me, but I think I remember it was 50 something. Let me grab my phone. Calculator. Oh, where'd I leave you? There you are. I have to edit that. All right. 51.02. So this is equal to 51.02. And then since I've canceled these out, the only unit that I have left is kilograms. And kilograms is the correct unit for measuring mass.